Hello everyone, I am Sainath Chaitanya, Assistant Professor in Department of ECE, and for the current semester I am going to deal with the computer vision subject for you. Before knowing what is a computer vision, we should know what is generally a vision. Vision is a sense by which the qualities possessed by an object in our environment are projected through the light rays into our eyes, after which these are transformed into the signals that are passed to our brain for making us to react. This is about a vision. In simply, I can say that it is an act or a power of seeing. So we do have here a many definitions for the computer vision. So a computer vision is nothing but we do have a many number of cameras or a single camera that is linked to our computer systems, after which the computer interprets the images of a real scene to obtain the information. That means here image analysis is happening. This analysis is used for our task like navigation or recognition or manipulation or any other act. So in the some other definition is, it is a discipline that studies how to reconstruct, interpret and understand a 3D scene from the given 2D images in terms of the properties of the structures or objects which are present in the image or a scene. This computer vision, the main objective is here to build a machine where that machine can process, interpret the images or the videos just like how our human visual system does. I can say it is just like a complement to your biological vision system. So this computer vision system is nothing but it is a complementary for your biological vision system. So you can see here I have depicted the differences of computer vision with image processing as well as with computer graphics. So what is this image processing and computer graphics are different with this computer vision? Generally a computer graphics is nothing but it represents a 3D scene if it is given with a 2D image. So here I am having, you can see the computer graphics is this one. So it is a representation of a 3D scene into a 2D image. So this is my 3D scene because where I can see a side view and I can also see a front view and I can also see here a back view also. But coming to here in this image, I can only see a 2D image. That means a computer graphics is nothing but it sends the model or a 3D scene which may either be a text or it may be a numerical data or it may be a kind of any model like this or sometimes some kind of a geometrical data also I can give to it as an input, after which the computer graphics will produces a 2D image where in this 2D image I can able to represent my 3D scene here. So by using this computer graphics I can develop the video games, animations, some kind of drawings also will be developed here. So what is this image processing? Of course you people are very familiar on this topic, that is image processing. It is simply operating on images and to produce other images, operating on the given input image and we are going to get some other images. So it is nothing but a image to image transformation. That is a 2D image to 2D image transformation. But what is happening in the output? So during this time of image processing, I may have my visual quality of the input image increase. I may have the noise removal of the input image, and some kind of processing activities I can do, like compression, image recoveries, like denoising, deblurring. All these things comes into the act in the image processing. So image processing is nothing but a 2D to 2D conversion. But whereas computer graphics is nothing but it is a 3D scene is converted into a 2D image. Okay. Now let us see what is this computer vision. This computer vision is nothing but it is a image analysis it will do. Like it just recovery of information about the 3D world from the 2D images it does. So like image analysis, scene understanding, or what is happening in the given scene or in a given environment or in a given image, like anything is happening, or like how many number of vehicles, two-wheelers or four-wheelers are present in a given traffic image, and how many are violating the traffic rules. All these things a computer vision gives us the output. Okay, that means it is just an analyzing activity it does. It is image analysis or a video analysis. This is the purpose of the computer vision. So I can conclude the computer vision here as where it is a transformation between the 2D images into a 3D scene or a 3D world. So this is about computer vision. Now, the same thing I have projected here, the computer vision. Here the arrow mark you can see. I am having here a 2D image which is having the objects of a sphere as well as a cuboid. So by seeing this 2D image, the computer vision, what it gives us, it gives us the data. What data? Some numerical data about the qualities or the characteristics of a sphere or of a cube, and what is its radius or what is its spherical coordinates. Some kind of numerical information we are having a chance to produce in the computer vision. That means it is an analysis of the image. But coming to here in the computer graphics, as I have said earlier, it takes the inputs of any numerical data or text or information and it just produces the output as a 2D image. So this is about the computer vision and computer graphics difference. Okay. Now, so what is this computer vision? Where does this computer vision came into picture? Okay. Now, we know that artificial intelligence is mimicking the human intelligence. That means it is like to stimulate the human intelligence, the artificial intelligence act is. Okay, so this computer vision is related with many number of disciplines, like we do have here many number of disciplines like machine learning, cognitive science, algorithms, image processing, computer graphics, artificial intelligence, like speech and natural language processing. We do also related with neuroscience and system architectures, information retrieval. All these interdisciplines it is related with. That means I can say my computer vision, it is at the intersection of multiple scientific fields and it brings together a large set of disciplines into a one platform. This is about computer vision disciplines. Now, this computer vision has come from the artificial intelligence, under which we have the machine learning, And in the machine learning, we do have here some learning algorithms. Under the machine learning, for further analysis, we go for the deep learning. And so computer vision, in this way, it is related with the artificial intelligence. That means it is wrapped by the deep learning, machine learning, as well as the artificial intelligence fields. Okay, and as I have said you that computer vision, it is related with many number of disciplines like this. Okay, so what is the difference between a human vision and a computer vision? So in the first left half side, what you can observe here, it is a biological vision. Right side is the one, it is a computer vision. So a person standing here with a camera and shooting some environment scene, so this is what we can see. This is biological vision. That means what we can see is depicted here, but what computer sees, so computer will see only the numerical data. That means from the image, it is analyzing some numericals. It is seeing. So what all these numericals are nothing but here. These are the pixel intensity values. These are the pixel intensity values of the given scene. So this is of course a grayscale image. So the highest grayscale value for a grayscale image is 255 and the lowest value is 0. Lowest value stands for it is a black region and the 255 stands for it is a white region. Okay, now so what is happening here? So I am just projecting here a and making you out a difference chart with the computer vision system and human vision systems. So I have here some kind of a fruits which are kept inside a bowl. So this is my input image. So in the human vision system, the eye is acting as a sensing agent. So this sensing agent will be responsible for capturing the environment or the scene. So after capturing some data, this is forwarded to the brain. Now the brain, what it does is it is just interpreting what is present in the image, and it interprets the data and produces the output, that is interpreted output. So that means here I am having a bowl, inside it oranges, banana, lemons, peaches, etc. The same thing your computer vision system also do, where the eye is replaced here with a camera or a sensing device, and we do have here inside it a processor in the interpreting device, and some kind of algorithms will be present for interpreting the data or for classifying the objects inside the images. That means a future extraction, after which followed by the interpreted data. That means that what are the objects that are present in the scene. So this is the output. Okay, so this is about human vision system and the computer vision system. We can also take here few more examples, like yeah, here I have also depicted in this chart in simple way of understanding. That is, in a human vision system we do have a seeing, and after it processing and intelligent decisions. Who will take the intelligent decisions here? It is the brain. And in the computer vision system, here the scene is being acquired by the image acquisition, which is done by the camera. After it is sent to a image processing. Next is some kind of machine learning or computer vision algorithms, so like a pattern recognition and some artificial intelligence algorithms, which are highly helpful here for decision making, that is intelligent decisions, like what is present in the given 2D scene. In fact, it is an image analysis. Okay, the same thing I given here for making it out a bit more clear. So this is some kind of a traffic scene it is. So this is sent to image processing unit, because acquisition is done by the camera, it is sent to image processing unit if any noise or enhancement or any deblurring purpose. the image processing gives the output. Now the algorithms of the computer vision will taking care of what are the objects or what are the features that are present inside this image, which are useful for interpreting the scene, the 2D scene. So this is how we are going to get the output as interpreted data, like how many number of persons, passengers are there, number of four-wheeler vehicles, so, and two-wheelers. So this kind of data we can get here as an output. Okay, so that means I would like to summarize what are all the things a computer vision uh, this needs. A computer vision needs, like it is just like a image acquisition, next pre-processing, future detection present in the images, and future extractions from the given input image, and after that we can do the classification. So we all are very much familiar with the MATLAB tool. Inside our MATLAB tool we do have a plenty number of toolboxes. So image acquisition toolbox will take care of this process, this stage, and image processing toolbox will control or will monitor the pre-processing activities, and the computer vision system toolbox, which is present in the MATLAB, will enormously support these two activities, that is a feature detection as well as the feature extractions which are present in our given 2D images. After this I can able to do the classification. That means what kind of an object I am seeing is being taken the support from the statistics toolbox. So this is the algorithm stages of your computer vision algorithm. I can compare my technical system with a biological system. So high is my biological system. Technical system is what? It is a mechanical device that is called as a camera. So the most common functionality includes for these two systems to work or to act are the radiation source. Because if no radiation is emitted from the scene or object, nothing can be observed. Because here you can see in this image, if there is no radiation is emitted, can I able to see? Everything will appear dark. Okay, that means radiation is must. So I can see here illumination is necessary for objects that are not radiant, because here passenger, it is a not radiating body, so illumination is definitely required for the objects which are not radiant. So what happens now? A camera or the eye, okay, these collects the radiation from the received from the object, that is a light photon. Okay, a light photon is getting converted into electrical signal in our eye or a camera. So in eye, how this light photon is converted into an electrical signal? The retina of your eye will take care of it. And in the camera, the photo sensors will take care of it. So this is the sensing device, sensor. This will take care of in converting the into a electrical signal. So after this electrical signal, so as I said you that the sensor converts the received radiation which are emitted by the objects and converts into an electrical signal for further processing. Okay, so I can say here, let me be more clear on this topic. Why? Because it is highly important to differentiate out what exactly a camera and what exactly an eye, for which let me make out some differences. So in the right side you can see a human eye, and in the left side you can see the computer eye. So the human eye is having a cornea. This is replicating the camera lens, and in the camera view we are having the aperture. So you can see here aperture plates will be present. Okay, anyhow, aperture, this is the aperture, and it is surrounded with some aperture plates. Okay, similarly in our human eye there will be a pupil. This pupil is replicating an aperture. This pupil is replicating an aperture, and the pupil is wrapped with a iris here. Aperture is wrapped with the aperture plates. Okay, so like we do have a room. Inside our room windows are present. So windows are nothing but these are a mean by which a light can enter into our room. Okay, so if I don't want the light to enter into our room, means what I do, I just close my window doors. So window doors are nothing but here aperture plates, and iris is nothing but aperture plates or iris, and here the window is nothing but the aperture or the pupil. Hence, I think you people have got a clear understanding on it. So after which, in my camera, I do have a sensing device. This sensing device will convert the received radiation or the flux into the electrical signal for further processing. And here, the retina of your eye will be taken care of. Okay, so in brief, I can say that the cornea of your eye is just controlling and focusing the entry of light into the eye. Okay, and the iris will take care of the colored part of eye. That means it regulates the amount of light entering into the eye. That is, when there is a bright light, iris closes the pupil. Here you can see that when there is a bright light, iris closes the pupil, and the iris closes the pupil to let some less light. Okay, if in some cases if I am having a low light, so what happens, the iris opens up the pupil to let in more light. So in this way it focuses the light rays onto the retina of your eye. Okay, now I think you people got a clear understanding of how our eye works, right? So next, coming to the pupil. So pupil, as I have already said you, pupil is nothing but it is a window of the eye which lets light to strike the retina. Followed with, we do have a lens. So the front part of your eye, as I have said you, it is a cornea, and the lens help to focus the light rays onto the back of the eye. So that means this cornea, it takes care, okay, and focus the light rays onto the back of your eye. So this is my back of the eye. Okay, that means it is a retina. Okay, so all these things sensing, that means here in a camera sensor is important, and in a retina, sorry, in our eye retina is the important one. Now what is this retina? So the cells in the retina, what it generally does, it absorbs and convert the light to electrical signal or electrochemical, some kind of an impulses it generates. Okay, so which are transferred along the optical nerve which is present beyond it, and after that the messages will be passed to the brain. What kind of messages? That means the messages nothing but a scene message. So in this way the retina do. And so I said you that retina is connected with the optical nerve. So this optical nerve transmits all the visual information, like which may be a brightness, which may be a color, or which may be a some kind of perception or contrast of the scene. All this sensing information, the optical nerve will carry all this information into our human brain through this visual pathway. Okay, so this is the visual pathway. That means first thing what I am having here, cornea. After this I am having a iris, pupil, lens, retina, optical nerve, and then lastly we do have brain here. Okay, now let's talk about the camera now. So in simply I would like to describe you the components of the camera here. I am having the camera lens. You can see here these are the lens of your camera. So it is a tool actually that is used to bring the light to a fixed local point. So after this I do have an aperture. So opening of lens diaphragm. So I said you right, this is the lens, right? So opening or closing of the light. So diaphragm through which light passes. So a bigger aperture if I am having means a bigger aperture hole lets you more light, and a smaller aperture will lets you a small amount of light. Okay, now so here I actually have a kind of thing that is you can see here. So these are the lens of a camera, a convex lens. Let us consider this image, the center image. So the convex lens can be moved forward or it can be moved backward so that my focus levels on the object varies. So if it is moved forward like this or if it is moved backwards for this, so I can particularly focus on one object in the scene, or if I move backward I can concentrate or focus uniformly on the entire scene. Some kind of theory will be present here. So this is the concept of convex lens. But in our human eye, what happens? The lens of the eye, that means this one, the lens of the human eye, this can't be moved forward or backward like this, but can change the shape. That means the shape of the lens changes. If it is changes, definitely the focal length can be changed so that I can specifically focus on an object more clearly depending upon my requirement. That means the concept will work or will come into picture here is a focal length. So how this focal length is being controlled? It is being controlled by the movement of your iris. If the movement of iris makes the pupil or the lens size increases or decreases. So as I have told you that with this pupil size I can let more light to pass through the pupil or lens, or I can control the flow of light into the pupil. So this is how it works. Okay, so the most important concept in human eye or cameras is inverted images or the inverted scene. So it is an object. Let us suppose this is my human eye. Okay, this eye is seeing something and this is my backside, that is backside of eye is retina. On the retina I generally gets an inverted image. So as I have said, the retina will pass the information to the optical nerve and to the brain. So the power of the brain will make us to perceive what exactly present in the scene. That means it is the human intelligence, some kind of intelligence our brain is having, such that what is present in the environment, the same exact thing we can able to perceive here. So in the case of the camera, what is happening? So this is my shutter. Actually this is my shutter and this is my mirror and these are the light sensors. It is a traditional old camera, but let me explain you by taking this camera as into our concept to get the concept bit more clear. So this is an image of a cat and this is a camera front side that is having a lens. Okay, and this is my light sensor, this is shutter, and this is my viewfinder. Okay, so why this kind of mirror alignment is there, I will explain you now. As I have said you that retina is mimicking a light sensor, a sensor unit of the camera. That means on the sensor unit or on the retina, you are going to get an inverted image. So how this inverted image is converted into a straight image in the eye, the human brain will take care of it. But in the camera, some kind of mechanism is required. What is it? So the mirror, you can see the mirror in front here. The mirror in front of the shutter flips up. This one will flip up like this. It goes upside. Okay, it will go up. It will be going to flip up. So whenever the mirror in front of the shutter flips up, what happens? It generally blocks the viewfinder. So my eye is here, so my viewfinder, this is my viewfinder, that means my eye is present here. If this mirror plate is went upside, I cannot see anything. That means I am blocked to see anything. Okay, so the mirror in front of the shutter flips up and blocks the viewfinder in this way. Now what happens? The shutter, so this one, I can see that this is the shutter. Before it, the shutter was closed by the mirror. Now the shutter gets open and it lets the light to pass, and it lets the light part goes through the lens. So this is my light rays, right? It is slowly going through the lens of the camera to the light sensor. That means these lights can strike to the light sensor now. Okay, so but what I am saying here is, the mirror is flipping up or it is going up, it won't last for more amount of time. So as soon as the time is up, the shutter will be closed by the mirror, and the mirror, because the mirror is flipping back into its periscopic position. So the image is inverted when captured by the light sensor, because it is a light sensor, but the camera, which is having inside it a processor, will take care of in reorienting the scene or the image correctly, and after that it is written as a data file into our memory card. In this way it is happening. So here human intelligence will take care of this inverted concept, but here some kind of processor or algorithms which are present in a processor of camera will be taken care of to get the original image of a scene. Okay, so this is about the human eye. Again I have replicated, I am showing here. So when the eye focuses on an object farther away, the lens exhibits its lowest refractive power. So these all are the refractive power, all these things are the concepts of photometry. I will describe all these things and discuss in the next class. So when the eye focuses on a nearby objects, the lens is more strongly refractive. So this is my optical nerve, this is connected to the brain. So you can see here, this is my retina, backside of the eye. So here the blue color, this blue color I didn't get straightly here, I got inverted. I got here as inverted. So this is about human eye. Okay. Now, so what is happening? All these things like objects present in the scene, how I can able to see on my gadgets, how these all are visible, what is the concept which is making us to feel the objects to get displayed on my electronic gadget. That is the concept now. Okay, so some two people are standing under the sun, a boy and a girl. A camera it is acting as an observing agent. It captures these two. So the captured environment is seen. What does is being captured by the camera. So I have gotten images as an output. So this image, which will be in analogous nature, is digitized and sampled. That means sampling and quantization will happen here. After that, I need to store the data file at some place. That means a digital storage is required. So some kind of a memory card, or some kind of any memory chip or card holder. After this, the processor, generally what it does, it takes the input from any storage unit and processes it immediately or at the spot. So the processed output can be streamed lively, or it can be stored, or it can be buffered directly to the cloud, or it can be streamed lively and can be transmitted to our electronic gadget, by which we can able to see on the display screens. So the entire activity is like, the light is reflected by the object, camera converts the light photon into the electrical signal. So we got electrical signal and we get an image, that is analog image, which is converted into a digital image by the spatial sampling, that is sampling along the x direction and after that along the y direction. Okay, where we get a 2D array of numbers, and this information is stored here and processed here and streamed or buffered, and we can able to see in the display screen. So this what I have demonstrated, the same thing I have figured it out in this way. So acquisition, sampling and quantization, this is all the image processing activities, image enhancement or segmentation. These all comes under the, what do you see, it is image processing activities, and feature extraction, object recognition, image interpretation a computer vision will take care of. So this is my some kind of an input image, pre-processing and segmentation. So some object I got here. So from this image, future extraction is done. So after getting the future vectors, I will be classifying it. So through some learning algorithms, and I can able to find out what is present inside the image. So now a digital image is there. So how this image is obtained, right? Because the environment, what we feel, and when it is being captured by the camera, we generally a RGB color image we face. Okay, so keeping aside RGB, which is of 24-bit depth of each pixel. Now let me discuss about the grayscale image. That RGB image is getting converted into a grayscale image, which is a 8-bit for each pixel. That means 8-bit depth, pixel depth is 8-bit. That means I can have a values or the range of my grayscale level from starting with 0 to 255. So I have taken some image from this environment. A portion of the image is this one. So this is a digitalized image, as sampling and quantization is completed here. So for every box, I am having here a unique number. For the box which is completely black, it is logic 0. For the block which is completely white, this is indicates logic 1, or it is a highest value of your logic grayscale levels, that is 255. So in between the black and white, we do have many number of gray levels like 22, 38, 68. That means as you are moving towards 0 means you are moving to darker side. As you are moving towards the 255 means you are moving towards the brighter side. Okay. Then how these images are obtained? Right. Because the ultimate the source of energy, or how the images will be happened, is the source of illumination. So what is this source of illumination here? So like, as you know that the electromagnetic spectrum is having different rays, like gamma rays, x-rays, ultraviolet, visible, infrared, microwave, radio waves with different wavelengths as well as the frequencies. As the wavelength increases, the frequency decreases. It is an inverse concept. Now, among this electromagnetic spectrum, I also have the visible light. So, which may roughly start with 400 nanometer approximately and ends with some 750, 800 nanometer. So, in this visible spectrum of light, I do possess many number of colors like violet, blue, green, yellow, red, some kind of orange. Okay, like this. Different colors are present in the visible spectrum of light. So, based on the electromagnetic spectrum, I may get here X-rays, visible region images, IR images, like radar images also I can get, ultrasound images, like medical images, mammogram images. So all these types of images I am having a chance to produce based on the input radiations what I am taking here, or sources, input sources of your rays. So based on this source of illumination, I may have here all these number of images. Okay, now, so like the computer vision, in summarizing, I would like to summarize what the main applications or the advantages in learning out the computer vision is. So the computer vision system is having a plenty or enormous number of applications in various fields. As I have said you, it is an interdisciplinary field. Like I have here optical character recognition, like number plate recognitions, or some machine inspection, like for example if any part in the machine is fault, so by using this computer vision we can do the machine inspection analysis. Medical imaging, like for example any diseases is there, so like you to perform some kind of long-term studies on brain or some blood vessels tracking cells or how the nervous system is, and some visual navigation and surveillance, like surveillance mainly we use for monitoring the intruders, analyzing the highway traffic or any violations in the traffic. And we do have here fingerprint recognition for biometric purpose, all these things, automation, segmentation, human computer interface, many number of applications your computer vision system is carrying. The biomedical engineering also, like virtual surgery, CT scan, MRI, detection of tumors. And apart from that, we can also have a computer interaction by using the hand gestures. Of course you are familiar with this one. Okay, so like faulty detection in any VLSI chips boards, etc. So by this I would like to end of the session, and in the next session we will see and discuss few more concepts.